In this video, I'm going through parametric modeling. The idea behind parametric modeling is that we can go ahead and create an object that has only a couple reference dimensions, and then everything else references those and changes as we change those dimensions. In this example, we can see the layout of the model that we're dealing with. If we go ahead and scroll down in that model, we can see that D0 is set to a certain size. Other than that, taper angles are about the only thing that is set to a certain size. Everything else references it. So for example, we can see that D0 is 3 inches and that D1 is supposed to be 5:3 ratio. So if I'm going to create this in Inventor, I'm going to try to follow along the technique that they give us. We may not match all of the D numbers, but I'm going to try to do the best I can. So if I go into Inventor here, I'm going to start a new part. I'm going to do a standard.ipt. I'm going to start a sketch. I'm going to start laying down here. And I'm not going to apply any dimensions as I create my original rectangle because I want to be able to add them after the fact. Notice that each dimension is given a D number. So right here is D0. I know that's supposed to be 3 inches. I can zoom out and apply this dimension, and I know that's supposed to be a 5:3 ratio to D0. This is also D1, so I can kind of follow along with the image and make sure that I'm putting them the correct places. This image walks me through where each D number should be. If I go ahead and delete a dimension, it burns up that D number, so we probably don't want to do that. We want to use undo. This is supposed to be a 5:3 ratio. Don't just type in 5, otherwise it doesn't work. So I'm going to do D0, and then I could take it times 5 divided by 3. I could do multiple ways of doing this, but I'm just going to take it times, and I'm going to put it in parentheses just in case it has issues with order of operations. So times 5/3. So right there I've created my equation. We'll notice that it calculates and takes care of it for us. If I go ahead and extrude that, it tells me that I want to extrude this for a thickness of D2. D2 is supposed to be 20 times smaller than the overall width, and if I'm looking up here, my overall width was my D1. So I could go ahead and take D1 divided by 20 would give me that solution. Okay, it looks like it's glitching up just a little bit, but we can see up here it's allowing me to type it in. So D1 divided by 20, and there it brought this back to the front screen that I'm dealing with. Next, we go ahead and deal with putting the slot in. I can see that when I come over here and I'm looking at the order of their dimensions. So when I extrude, that was D2. D3 was the taper angle that it automatically took care of. If I come back in here and go into my extrusion, right there is my D2. In the More tab, right there's my taper angle, which is my D3. If I change that number, it actually puts an angle on my extrusion. We usually leave that as 0. That's why we don't worry about the taper angle dimension. If I go ahead and start another sketch, I could start a sketch here. There's lots of ways to make the slot. I'm going to go ahead and just make a quick circle here, quick circle over here, take a line that connects the two circles. I'm going to make it obvious that it's not the correct line. That way I can apply some geometric constraints and go through that as well. So I'm going to do a tangent constraint between the line and the circle, the line and the circle, the line and the circle, the line and the circle. I'm going to set both circles to the same size. And I'm going to apply a horizontal constraint on one of the lines. Notice that my view is turned. I probably actually want a vertical then. So I'm going to just undo that and apply a vertical constraint on one of the lines. So I've started to create this. I can trim it up to get rid of these little arcs, and now I'm ready to start looking at my dimensions. So if I come into my Word document, I can see that D4 is the width of the slot, D5 is the distance from one edge, D6 is the distance from the other edge. So if I scroll down, D4 is supposed to go ahead and be half the overall plate depth, which was my D0. So I'm just going to come back in here, dimension, center circle, and type an equation based on what I've seen. Let's see, then it comes over to the edge. I can dimension that. And there's lots of ways you can do this. I'm just coming up with some equations here based on what I think I remember from the sheet. Ideally, you'd be looking back at this sheet every time to double check, make sure you're doing it correctly. Okay, and we need a size on the circles. So the slot width is half. Okay, slot radius is D2. So if I put a dimension on here, it gave me that, D2. And right there's the size. I'm going to go ahead and look back at the sheet here. And I can see that this is a separate extrusion. So I'm going to be able to go back into Inventor, extrude this, cut, and I'm just going to go distance all so I don't have to worry about making sure it goes all the way through. I can create my other sketch here for this circle. And I'm going to go ahead and pretend that I'm the typical student that doesn't dimension everything and hope Mr. V doesn't catch it. And I'm going to extrude, cut, distance, all. Okay, then we can see that I've created and I want to check my solution. If I go into manage parameters, it's going to give me the list of everything. So it doesn't show that I skipped the dimensions, but this is where we find out when we change this number. So if I change this to 10, everything should scale uniformly with it, meaning that it should look the exact same, only larger. And we can see that the slot scaled like it's supposed to, the thickness scaled like it's supposed to, but that hole obviously was not done correctly because it didn't move where it's supposed to, and it didn't change size like it was supposed to. That's the idea behind parametric, is that I can come in here and change this value, and everything that is supposed to change changes. So that is how I will check the assignment when it's done. I'm not going to go through how to locate that hole. You should be able to figure that out.